As you know, LeanHDX is an online tool. So to get started, navigate to myleanhdx.com and log in. Once you've done so, you have the option to open an existing project as well as to start a new one. Today we're going to go ahead and create an outpatient clinic. I'm going to give this a little bit of a description and hit OK. Once I've created a new project, I need to create scenarios. Typically, I'm going to start by creating my base case. I'm going to choose not to launch the tutorial today, and I want to use the default background image. If I don't choose that, I can select from my computer any sort of JPEG, PDF, any other image background that I would choose. I'm just going to hit OK. So for today's purposes, we're building a new outpatient clinic, and we're interested in experimenting with a number of different layouts in order to understand whether the waiting room is large enough, where the best place is to put the staff offices, and how many rooms we need in order to meet demand. There are two types of patients that enter the clinic. I'm going to go ahead and click and drag to create a patient entry point. We have two types of patients. The first is new patients. The second are returning patients. They arrive at a rate of about 8 per hour, and my new patients compose about 40% of those who come in the door, the remaining 60% being returning patients. Okay. Once I've set up that start point, it will generate 8 patients an hour, assign them to those two categories, and send them through the appropriate flow. I'm going to go ahead and select my new patients, and what that means is that when I create this flow is for the new patients. They are going to walk in and pile up in front of the reception, and the reception in front of there is actually going to have a little bit of a waiting area where the queue would form if there are multiple patients waiting. That queue is going to be related to this particular task of reception. So I'm just going to create this box and match it up to the space on the screen here. After reception, the patient will return to the hall here. They will move through the space and enter the large waiting room. Again, this is a waiting area, so I'm going to click and drag that to fill the space. From the waiting room, my new patients would re-enter the hallway and then come into the treatment room. The treatment room being where they would be seen. And again, I'm going to fill the space. This is just for visual purposes, so we can understand what space is being occupied. After the treatment room, after they've seen the nurse and also the physician, they're going to go back out into the hallway, move through the space, and eventually leave the building. So this is going to become a patient exit. I'm just going to slide this over a little bit so that I have space for both. Okay. So very quickly I can see how those patients are going to move through the space here. Now I'm going to also have a path for the returning patients, which is going to be similar, though a little bit different. So again, I'm going to select here. I've selected my returning patients. And in this case, I'm going to draw and drop it into the same location. From there, they're going to leave, go into the hallway as well, go into the waiting room, from the waiting room, they will go back into the hallway, but in this case, they will actually go to the treatment room. The returning patients will spend time in treatment room 2, so we need to create another task for them. Okay. We're going to fill the space. And then after the treatment room, they will leave through the same exit. Okay. This is an important result that we're seeing here. Even though we have not run the model yet at all, what we can see is where congestion may begin to build up in this facility layout. This is great. It helps everyone on the team who's using this tool to visualize how people are going to move through space and where there may be congestion. Once I have created my patient routes, I also may want to consider staff routes. So I'm going to go ahead and actually create a staff office. And you can see that this is not connected to anything yet. And if I click off of that, you see this green color with the stripes through it. That indicates that that is a staff base. I can have multiple staff bases in the simulation. And this is where I define what types of patients or what types of staff I have in the model, and will also be the location where they will start from and return to after their various tasks. This is going to be my staff office. And I'm going to add 2 types of staff today. The first being my nurse, and I have 1 of those. And the second being my doctor, and I have 2 of those. Okay. Once I've created them, I can also draw their layouts and their flow through the space. So if I click here again, this black dot comes up. I can drag that through the door and show how this staff will move through space. They will go to the treatment room 2, and they will also go to treatment room 1. Okay. So I've started to create those flows through space for the staff as well. Once I have the basic layout and flow set up, I want to go back through each part of the process and add some additional details about who does what and how long it takes in order to make this flow realistic. I've already set up my patient entrance, so we know that we have 8 patients arriving and what mix they are. Then they enter this kind of waiting spot before reception. So let's actually go ahead and name this waiting for reception so that we know what it is when we get to our results. Reception has a capacity of 1, which means we can see 1 patient at a time. And this particular task, this is just reception, and this is going to take 3 minutes on average. We have not assigned any resources to this task, so we'll just go ahead and update changes. And now that activity is there and ready to go. Patients enter the waiting room. This is going to be waiting area or waiting room. Again, unlimited capacity. We can take as many patients as we need. If they fill up, they'll stand in the waiting room or find some other space to be. We don't have to worry about overflow. For the new patients who go to treatment room 1, we again have a capacity of 1, and there are 2 activities that are going to happen here. The first being an assessment, which takes on average 6 minutes. And this does require a resource. This is actually done by the nurse. And then we're going to add a second task, which is treatment, which is done by the physician, and that takes an average of 12 minutes and requires 1 physician. Okay. Once we have that set up, that is all good to go. We also have treatment room 1. And we will need to do the same thing here and assign, this is just going to be treatment. Now these patients have already been seen before. They don't need any additional assessment. The physician already knows them, so he doesn't have to spend a whole lot of time with them. So that only takes us 10 minutes as opposed to 12 that it took us earlier. And this does require one doctor as well to complete. Okay, and you can see that that is updated here. Great. So once I've added these details, I can go ahead and run the simulation. And what you're going to see on the screen here are a few different of the results showing up. You can see the pink and purple dots moving through space. Those are actually our individual patients. We can also see green dots moving in and out of the office and to the treatment rooms. Those are our resources, our doctors and our nurses, as they travel from the room back to the office and back again. Our queues also have some interesting results. So right now in the waiting room, you can see it is entirely pink, which means that our waiting room, and you can see that line is moving, mostly the waiting room is occupied by new patients, but on occasion there are some returning patients that are spending time there as well. And that is true in both of our waiting spaces, before reception and the waiting room. You also see in the activities, the reception, the treatment rooms, gray boxes, green boxes, and red boxes. Gray means that the room is empty. Red means that the room has a patient, but that patient is waiting for somebody to come in and work with them. And green means that the patient is there and the resource is there, and they are completing the tasks that they need to get done. So we can watch this through and get a feel for how people are moving through the space, but I am going to go ahead and just speed this up and run this all the way to the end. Okay, this is our speed bar. We can slow it down to see the animation or speed it up to get the results faster. Once we've completed the simulation run, we go to Analyze for our results. You can see a few different key results here. On the summary page, we see the amount of time that our nurses and our doctors spent traveling. We can see our staff utilization, which includes travel and also the time that they spend doing the tasks. And we can see the number of patients in our system. It's rising, which is definitely a concern. We also have several other sections of results here that you can take a look at and to understand how your system is working. So the question then, once we've built a model that represents our reality, and we've validated that this feels like what our anticipated or our existing experience is every day, the question is, can we actually improve this? And I would argue that yes, there are a few things that we can do to help. First, we know that our staff are spending a large amount of time traveling, and of course that is considered a waste, and so we would like to reduce that amount of time if we can. Now conveniently, we do have our office set up over here on the left currently, and we have a storage space located over here. The question that I'd like to look at is, what if we moved this office over here instead? Yes, it is a bit smaller of a space, but if it saves us time, it may be worth doing. So I've moved the box. You see these arrows are still here, so I just need to click those and drag those back here. Okay, I'm just going to reset the model so that the staff are moving through space correctly. I want to bring these dots in closer together. Okay, because obviously they wouldn't walk across the hall and then back again. Once I've made that change, I simply reset and run my model again. And I've left it at full speed so that I can get to the results quickly. And again, once I've run that, I can go to Analyze and see the results for this most recent run. Now this is only one of the runs. This is the most recent one. And if I want to take a look at how the two different scenarios that I just looked at compare, I go to Compare Scenarios. And I'm going to go ahead and add my current result. And I'm going to add the first result here and hit OK. And now I can see the first run in that dark green color and the most recent run in the light green color. Obviously, we've had some success. We have reduced the amount of time that my nurses spent traveling from about 15.5 hours down to just under 8 hours. So that is definitely a great success. And we've also reduced the amount of time that my doctors spend traveling as well. Utilization is just a little bit lower, right? So that's good. Interestingly, the nurse utilization went up just a touch, probably because they're able to see more patients because of the shorter travel times. And we can also see that we have stabilized our system. So the number of patients that were in the system, right, in the office, was piling up pretty quickly in the first run, and now we've reduced that pretty dramatically. Now it may still be higher than we want, and so there are certainly additional scenarios that we may want to test. Let's just test one more scenario, and then I'll let you get on to testing this for yourself. And that scenario is related to the staff and how they move through space. Currently, by default, the staff will go to the treatment room and then return to the office. Go to the treatment room, return to the office. Perhaps we may want to reduce the amount of time that they spend traveling. They may be able to actually stay in the treatment room. And so we're going to go ahead and change their behavior. So for nurses, we are going to say, always wait. The staff member will go to the room and then remain there unless they're requested in a different location. I'm going to do the same thing for the doctor. Okay. I'm going to go ahead and do this one last time, reset, and run. Now this particular change is a behavior change for the staff, and we're changing how they wait for the next patient, which represents obviously a new workflow. This may require some investment. It may be supported by better in-room supplies, additional technology, so that they don't have to return to the office or to the supply base after every patient. And the question now is that worth the return on investment, right? Is the modification worth the additional investment in technology that we may need to make? So let's add our results again. Okay. And now we will see all three results. The dark green being the first scenario, the light green being the second scenario, and the blue being the most recent. And we can see how different things are happening, what impact that is having on our key results here, and we can make the decision about whether or not this is a good investment. Now the question always is, can we improve this further? And usually the situation is yes. There are many more scenarios that we could test with this particular layout, but I'm going to leave that to you to investigate, to experiment, and to learn how LeanHDX works. Good luck,